In the last exercise, we have seen how to define a function by ourselves. Okay, and we defined a function named LCM array that will perform LCM on all the elements of an array. Okay. Similar to that, there is another function called GCD that actually finds out the greatest common divisor between two numbers. And I would ask you to create a function by yourself named GCD array that will do the array-wise GCD function. Okay. So I hope it is no problem. Now we are going to look at this exercise. Okay. So this is called factorization. Okay. Just pause the video and read this thing by yourself, and let me explain it here. What is factorization? Okay. Say you have a number like this. Say for example 6. Okay. We can factorize this number into two prime numbers, that is called 2 into 3. 2 into 3 is 6. Okay. Now let's take a look at another example. First, we can actually divide it into 2 into 4. Now 4 can again be divided into two parts, that is 2 by 2. Okay. So as you can see, what we have did here, 2 is 2. Okay, and this 4 that we have divided the 4 into two prime numbers. Okay, so this is what we call actually. There are two types of number: composite number and prime number. Okay, so this 4 here is actually a composite number because it is not a prime number. This 2 and 3 was prime number. So whenever you have a composite number like this 6 is a composite number, this 8 is also a composite number. Any composite number can be divided into a set of prime numbers. Okay, so this is what we call factorization. Okay, this is what we call factorization. Factorization. Okay, so if we take a look at another example like 20, okay, we can first divide into 2 by 10. We can again divide the 10 into 2 by 5. Okay, so all of these three, this 2 to 5, okay, are the prime factors of this 20. Okay, and this is what we call factorization. Now if you look at in MATLAB, okay, there is a function, built-in function for that, that is called factor. Okay, so the factor of 20, so this is actually 2 to 5. Okay, similarly if I write factor of 200, okay, I get this thing. Multiplying all of these elements will give you this 200, and you can check it by, there is a function also for that. For example, product will give you the answer. Now this is what we call factor. So we learned a new function. Okay, so after LCM and GCD, we found a new function that is called factor, and we also saw another function called product. Okay, always keep these things as a list, like I said before. Now, so what is our question is asking? It is saying that find the. It is not saying this. We don't have to find the prime factors. We have to find something else. Okay, and this is called finding the proper divisors. Okay, so what is that actually? Now, so that is called proper divisors. Okay, so what is actually proper divisors? So for example, say our number is 10. Okay, if our number is 10, we can divide this number by 1. We can divide this number by 2. But if I divide 10 by 3, it is going to give us some reminders. Again 4 reminders, but 5 it is going to give us the number. Again 10, it is going to divide this number. So what it actually means that, so these are the proper divisors of this 10. Okay, the numbers that can divide this number without any reminders are the proper divisors of that number. Okay, so let's take a look at another example. Say for example, we saw 20, right? So the proper divisors of 20 is 1, 2, 4, 5, and 10, and the number itself. Okay, because we can divide 20 with these numbers without any reminders. Okay, now one thing is that every number is actually divisible by itself. Okay, 20 is always divisible by 20. So when it say proper divisors, we only mean this 5. We don't actually mean this 20. Similarly, when the proper divisors of 10, we don't actually mean this. We only means 1 to 5. Okay. Now the problem is there is no built-in function in MATLAB to do this task for us. So what we have to do, we have to generate a function by ourselves. We have to create a function of ourselves that will actually do this task. And you have already learned how to build a function in your last lecture. So we are going to do it again. Okay, let's take a look how we can do this. So if you remember, let's create a function. First we write this function. Okay, we give a output variable name, output parameter name, say out. Okay, we name our function, for example, proper divisors, say prop div. Okay, anything you can give by yourself, and it is going to take a number. Okay, so integer. And whenever I write a function, it has to be finished with an end. Okay, let's save it. If you type control save, it is automatically going to save in this file name. Just save it. Okay, it has been saved in this directory. You can say there is option like current folder. If you click on it, you can see all the functions, all the files that are present in the current directory. Okay, now how do we actually do that? Now how do we actually do this task? Our task was finding out the proper divisors of a number. Okay, how to do that? Okay, now let's try to understand that. Okay, say when I have like this 10, in your last lectures you were introduced to another function that is called modulo. This is actually called modulo operator. Other programming languages actually use other sign like percentage sign for that. Okay, but in MATLAB we use this function that is called mod. Okay, modulo of the number, say for example 10, and another number, say if I use 2, it is going to give me 0 because it doesn't have any reminder. The reminder is 0. If I again perform something like 10,3, it is going to give me 1 because the modulo of 10 by 3 is actually 1. The reminder is actually 1. So this is what it is doing. So say for example, if I have a number like this 10, if I have a number like 10, okay, and I have a list of another numbers like 1 to 10, 1, 2, 3, 4, 5, then 6, and dot 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 10 up to 10. Okay, I can perform this operation like this modulus operation. Okay, with this 10, and here we can actually each of them for 1, 2, 3, for each of them we can actually check this function. We can actually use this function. If our reminder is 0, that means that number will be a proper divisor of 10. Okay, are you getting me? Okay, let's take a look here. Say for example our number is 10. So if I write modulus of 10 comma 4, it is going to give me 2. So 4 is not actually a proper divisor of 10. But if I write 10 comma 5, it is going to give me 0. So 5 is a proper divisor of 10. So we have to find all the proper divisors of 10. Now you can actually write a for loop going from 1 to 10 one by one and writing the function, but we are not going to do that. We are going to do something like this. Okay, so first we want to create an array from 1 to 10. Okay, you know already by this. So if I created this array, it is like this. Now we are going to use the broadcasting concept. We can just write modulus of 10 comma a. Okay, so it is going to give me, okay, all the modulus, this operation of all the elements. So for 1 I have 0, for 2 I have 0, for 3 I have not 0, for again not 0, for 5 0. So these zeros, the numbers that are giving me zeros are our desired output. Okay, now how to actually bring out those things, that's the question. Okay, so you can actually do it in different way, but the proper way I would like to do is that something like this. If I write something like modulus of 10 comma n is equals to 0, because I want this 0, and if I write this way, this is going to return me a logical index, a logical array. So this 0 satisfied, so I am getting 1. This 0 satisfied, I am getting 1. This means this 1 means actually this one. This 2 is getting 1. This 3 is getting 0. This 4 is getting 0. This is what logical indexing means. Now I want to, from this array A, I want to bring out those elements that is providing me these ones. Okay, I have explained this several times, so I believe it will be clear by now. So we can do it like this way. Just simply we can just call it A of this, parenthesis means of this thing. Okay, let's just copy it. Of this thing, A of Atho is going to return the values of A that have this 1. This logical 1 means logical true. Okay, so if I write this, so these are the elements. Okay, so I hope it is clear. Try it by yourself. So how can I actually write it in function? So remember, when I'm writing a function, I'm using whatever it inside the function body. It is called the local variables, and this is whatever I'm writing here. This is the global variables. So I will write a function based on the local variables, not the global variables. And here we have already defined two local variables. This is the output variable out, and this is the input variable in. So I have to define our relation based on these two things. So I'm going to write out is equals to, okay, first we have to define an array. The A should be 1 is to n, like this way, because we are doing for 10. Now our 10 is actually n, okay, in this definition. So that is our array 1 is to n. Then we are going to write A of, okay, modulus of n comma a, okay, is equals to 0. This is going to return me these things. Okay, let's try to run it. We can just finish it. We can just copy it and call it here in our command window. Sorry, I didn't copy it. Let's copy it first. Okay, proper divisor of 10. So it is going to give me this thing. If I call it for 100, it is going to give me all the divisors. Now, if you remember one thing here, I said that this number should not be included. So I should exclude those things. So instead of creating this array from 1 to n, I could just create this array from 1 to 50, because when I have 100, so 51, 52 is never going to divide 100 by without any remainder. So it can, the maximum proper divisor can be 50. So I can just write it something like this, n divided by 2. Okay. Now if I write it, if I run it, so I get all the proper divisors of this 100, okay, excluding that one. And by doing this, okay, we have already halved our array, the array we are actually creating. That is actually beneficial while writing a program. Okay, so I hope it is clear. If it is not clear, let me just show it again. Okay, because this thing should not be, you should not have any confusion of how to use this logical indexing. Okay, if you are already clear, so you can just skip this portion. I'm just going to show you now. So when we did this, we did something like, first we create an array like this, 3, 4, 5. Okay, I'm excluding the other ones. Okay, so because we created 10 by 2, that is equals to half. Then we return something. So then in the next line we return something that is called, okay, let me write it similar here. Okay, let me just create it first. So if I write something like this, like modulus of 10 comma a, so this was our actually a. Okay. So if I write something like this, modulus of 10 comma a, I'm going to get that. Okay, I'm going to get one. I'm going to get 2 for here. So I'm going to get this one. But if I write something like 1 comma 1 comma 0 comma 0 comma 1, if I write something like this, modulus of 10 comma a is equals to 0, that means it is going to check which are 0. So it is going to return an 1, a logical true for that, and those who are not 0 is going to give me this 0. So instead of that, then we actually try to find out from this a who have, okay, in this a, okay, who have this identical of truth. Okay, this is 0, so it is not going to, this is 0, so it is not going to return that. It is not only going to return the ones that have 1. So what we did in the last line is that it's going to 1, going to give me 2, it is going to give me 5, because we write something like a of, then modulus of 10 comma a is equals to 0. So this is what we did. We actually skipped through all these two lines. Okay, okay, we just written it directly. You can also write it separately, that's completely fine. Okay, so I hope it is clear, and this is actually done. So let's finish this thing.